Hello everyone, my name is Sergio Palacios. I'm working with the Computer Science Department at Purdue and also working with the Aud Center at Purdue. And in this presentation, I'm going to introduce AGAPECert, an auditable, generalized, automated, and privacy-enabled certification framework through Oblivious Smart Contracts. Oblivious Smart Contracts is our new invention from the Auds team. So let's get started. First, we know that many solutions for accountability and traceability in the supply chain use blockchain technologies as a building block. Some examples, BeefChain, IBM Full Trust, RIPE.io. However, we know that blockchain poses significant privacy issues because data and code are replicated in all nodes in the network. So an attacker can eavesdrop the communication links or memory and computation in the nodes and derive meaningful information from those nodes or communication links. The problem is known as access pattern leakage. Access pattern leakage is a side channel attack in which the attackers can infer information about the encrypted data simply by observing access patterns. Let's show this attack using some electronic health records or encrypted electronic health records. And let's suppose that we want to run this aggregate query on top of those encrypted records. So the first thing that the compute engine or the first thing that the query engine will do is basically it will shuffle those records in the compute engines. And from this, the attacker can observe that during the shuffle, 4 records are assigned to the node number 1, and 2 records were assigned to the machine number 2. The attacker knows that diabetes is twice as common as cancer. And with this, the attacker infer meaningful information from the computation or communication links. The attacker can correlate a patient with a disease. So in the future, when this doctor or the patient accesses his or her records, then the attacker can infer that this specific patient has cancer, for instance. And from this example derives one important question, and this is how can we protect data while preserving functionality? And there have been many works using the cryptographic approach, using fully homomorphic encryption. We also have the CryptDB that offers more practical performance, but has limited functionality and also is not distributed. In this presentation, we're going to concentrate all efforts in trusted execution environments. And we have one work from Berkeley, which is called Opaque, that is a cloud-based solution with oblivious operators, but it's not auditable. Further, some solution that uses blockchain and trusted computing includes IBM with a cloud-based solution, computing on top of encrypted data. But you may be wondering what is a trusted execution environment. And you can see this as a trusted black box in which you inject your encrypted private data in your certified code and you obtain an encrypted result from a derivative from the code and the algorithm that you run on top of your private data. And with this, you obtain privacy preserving computation. And we keep the data ownership, and we determine a trust relationship between the data owner and any participant in the protocol. So the main goal of AGAPECert is basically to enable a trusted server provider or data owner that perform the trust transformation in this figure to be augmented or replaced with code agreed upon by both the regulator or the participants and the data owner, as shown in this figure. So our proposed solution includes a novel mix of remote attestation guarantees of trusted execution environments and the auditability features of blockchain technologies. Blockchain is optional and it depends on the use case. And also we use a graph-based API as a trusted data store. We use off-chain computation. So we store a minimum schema consistent of untraceable cryptographic hashes in the blockchain. With this, we invented Oblivious Smart Contracts that keeps off-chain business logic. We have computation verification. We provide trusted code. We have integrity, protected computation and data, and we have privacy-preserving computation. Therefore, we define Oblivious Smart Contracts as software code that contains agreements between the regulator and data owner, or the data owner and any other participant in the protocol. You can see this as a trusted algorithm that obtains a pass-fail outcome from the private data, from the encrypted private data. In particular, Oblivious Smart Contracts produce private automated certifications. As we mentioned, we store a minimum set of cryptographic hashes in the ledger for the trust level number 3, and the attacker cannot derive any meaningful information from these cryptographic hashes because this has been shown to be computational infeasible. We want to show AGAPECert deploy using one use case. And for this particular use case, we're going to use certified phishing catch area. Let's suppose that the global phishing industry would like to eliminate overfishing by requiring phishing vessels to catch fish only in approved areas. So what we like to do is basically certify that the fish was caught within legal boundaries, and also protect the privacy of cache locations, since this will be our secret sauce or the data owner's private process. We now introduce the trust levels for AGAPECert. The first one, or owner attested, the regulator or consumer of a particular PSC trusts the data owner to faithfully execute the OSC, and therefore does not require proof of correct execution provided by a trusted execution environment or a trusted black box. The next trust level is trust level number 2, or enclave attested, and for this particular use case, or for this particular trust level, the regulator or consumer of a PSC requires attestation that the OSC or the algorithm was executed faithfully. The last trust level for this AGAPECert is blockchain attested, and in this, the regulator or consumer of a PSC requires proof of correct execution as well as proof of event ordering for issues like double spending prevention. In our example application, the certified phishing catch area, we want to certify the fish was caught with the legal boundaries, and also we want to protect the privacy of catch locations. So we want to ensure that the fisherman uses the AGAPECert broker and their OSC-enabled trellis platform to authorize and run the OSC, producing the certification back to the trellis platform. And this represents a trust level number 2, or enclave attested, computation where the global fishing industry would like to know that the code was faithfully executed by the fisherman. We now talk about the AGAPECert architecture, and as you can see, the main components includes a graph API, or graph-based API. In this case, we use a trellis data store. We use also compute engines, and this can be in-memory compute engines such as JavaScript, in-browser JavaScript, also Node.js, or if you use Intel SGX, it has to be a C or C++ compute engine. We also have the broker, which is a service manager for the OSCs. And we have the blockchain gateway, which is a generalized blockchain API or gateway. You also have the regulator, which is any other participant that acts as a regulator or a verifier of the PSCs, Our example application, basically the certified phishing catch area, we certify the fish was caught within legal boundaries and protect the privacy of cache locations. And we use a OSC to retrieve all the data from the trailers backend. We produce a PSC. We want to provide proof that the code run faithfully, so we have the hash of input data in code. So we provide the code was faithfully executed using a trusted black box or enclave. So for our simple application, we have the certified phishing catch area is an example of trust level number 2 or enclave attested. We protect the privacy of cache locations, and we certify that fish was caught within the legal boundaries. If we want to enhance this example to trust level number 3, we just need to include digital signatures and tamper-proof and immutable data stores. And we can also provide record verification and transparency using a blockchain gateway as we have. Now we explain one of the main components of the AGAPECert. This is the broker, which is a service manager to run and to interact with the OSCs or Oblivious Smart Contracts. And this is the web app, and it uses WebSockets and connects to the blockchain gateway and to the C++ compute engine. As you can see, this provides the means of the trust level number 3, trust level number 2, and trust level number 1 for a big amount of use cases. We now reached the end of this presentation with some concluded remarks. We have that Oblivious Smart Contracts are built using trusted execution environments and blockchain technologies. Also, Oblivious Smart Contracts produce private automated certifications, and AGAPECert gives you Oblivious auditable computation on commodity hardware, automating the certification process. Thank you for your attention.